Hi everyone, this is a demo on two types of probabilities. Actually, I make it three types. Union, joint, and conditional. Okay, so we have two events. Normally in a problem, it will not say we have two events. You'll have to read the problem and read the question to know what are the relevant events for that particular problem. So we have two events, milk and cookies. A joint probability will be P of milk and cookies. The keyword for joint would be and. You know what? Let me make it a question. What is the probability that Jane likes milk and cookies? The keyword is and. And is a keyword that helps identify joint probability. So when I read that question, I write it in a probability format. That would be P. That would be P of milk and cookies. Keyword is and. What is the formula? Actually, you know what? Let me start with the union. There's a reason behind it. And the joint will be last. For the joint, we have to rearrange the formula. That's why I prefer to start with union. So what is the probability that Jane likes milk or cookies? The keyword for union is or. When we see or, we know it's union. Not only because the word helps identify union, but also that specific word is connecting or is related to two relevant events. There's a reason why I'm saying that. So we will write P of milk or cookies is equal to the formula for union is the sum of the two marginals. Marginal refers to one single event or a single event. P of milk plus probability of cookies. Then we subtract the joint. We subtract the joint to avoid a double count. Let me write it below. So we have first the union is equal to two marginals minus minus the joint. So to find a union probability, we take the two marginals, we add them up, then we subtract the joint. That's the formula for union. Let's move to conditional. The question is, if you like cookies, what is the probability that you also like milk? Okay. The keyword that will help identify a conditional probability is if. The moment that I see one of those keywords, there are more than one. It could be if, when, given, of, and knowing. We write it in a probability term, so it's P. Then I put the bar. And I close the parenthesis. When it's a conditional probability, there is a bar. A conditional probability relates to two events. Right after the bar, we put the condition. How do we identify the condition? It's the event that is right after the keyword. If you like cookies, the event right after the keyword is cookies. What's the probability that you also like milk? P of milk given cookies. How do we find that probability? It's the joint of both events. Milk, I already have it written. I'll just copy and paste. It's the joint divided by the condition. To find a conditional probability, we take the joint of the two events, then we divide it by the condition. Probability of milk given cookies. Cookies is the event used as a condition, so it will be in the denominator. The next question. Let me leave a space. What is the probability that you like and buy milk? Oh la la. What is the probability that you like and buy milk given that you eat cookies? So I don't see if, but I see two keywords. I see and I see the word given. And we know helps identify a joint probability. Given helps identify a conditional probability. But those keywords must connect two relevant events. So let's read it again. What is the probability that you like and buy? We know that like is not an event, buy is not an event for the problem we are trying to solve. That's why I like using the word relevant events. The events that will help us answer the question or solve the problem. That's what I call relevant events. When you're reading a scenario problem, there will be several sentences and several words in one sentence. You have to know how to identify what the relevant events are. So, and in this particular question does not relate to a joint probability. So that question is conditional. Why? Because it uses the word given, and given is connecting two relevant events. What is the probability that you like and buy milk given that you eat cookies? With the word given, I know I have to put the bar. And the event right after the keyword will be the condition. And right after given, I see cookies. And we use the same formula as the one above. It's the joint of the two divided by the condition. Let me flip it now. If I were to say, let me remove this. I'm changing the question. That you like and buy cookies, given that you drink milk. That's how I should have written it in the first place. Okay. So again, the and, it only connects like and buy. So it's not relevant for this particular problem. So we have P, we put the bar, given. The event right after given is milk. Now the condition is milk, and the event being affected by the condition is cookies. Probability of cookies given milk is equal to the joint Oh, let me write it like that. Milk and cookies divided by it's the joint of the two divided by the condition. Question 1 and 2 are not the same thing. They are different. In the question 1, cookies is what we use as the condition. In question 2, milk is what we use as the condition. That's why the denominator is different. Aside from that, in the numerator, we have milk and cookies. Let me write it differently. Cookies and milk, same thing. Cookies and milk, milk and cookie, yes, we can interchange them. And it's the same. Okay? From that conditional formula, we can find the joint. And the joint will be, we cross multiply. Let's take it from number 2. So that would be P of cookies given milk multiplied by P of milk. That's how we get the joint. Okay? So we work on the union. That's the sum of two marginals minus the joint. For the conditional, it's the joint of both events divided by the condition. And for the joint, it's simply a rearrangement of the conditional formula. We simply cross multiply. Okay? And that's it for this one. Hope you like and understand. Hope it's clear enough and it helps you. Okay?